right, test 4B. And let's start with number 1. Write the equation y equals mx plus b form. So I've got, what have I got here? Y minus 8 negative 3 times x plus 4. Add 8 to both sides. Y equals negative 3x minus 12 plus 8, which is y equals negative 3x minus 4. Number 2. Same thing, I've got y plus 3 equals 4 times x plus 7. So subtract 3 in this case. And we've got y equals 4x plus 28 minus 3, which is y equals 4x plus 25. Okay, this gave us some trouble, some of us. I got 2 points. I have to find the slope. So m equals, what was that? Negative 2 minus negative 4. Or I could say it like I usually do, but maybe I will. I'll stay consistent here. So I'm going to have negative 4 minus negative 2 over 0 minus negative 5. That's negative 4 plus 2, which is negative 2 over 0 minus negative 5 is plus 5. So it'll be negative 2 over 5. And I'll use this point of 0, negative 4. So what will I have? Y plus 4 equals 0 times x minus 0. Okay, subtract the 4. I'm sorry, oh my gosh. This is negative 2 over 5. Let's do that right here. Right, negative 2 over 5. That's my slope. And there's my 0, so we're okay. So I'm going to continue on, subtract 4 here. So what have I got? Y equals negative 2 over 5 x minus or plus 0 minus 4. Okay, then you can see my last step is that y equals negative 2 over 5x, and that would be minus 4. Then it says put it in standard form, so I got to multiply everything by 5. 5, 5, 5. When I do that, I end up with 5y that equals negative 2x minus 20. Then I can just simply bring my x over to the other side by adding 2x. And then my final answer here is going to be 2x plus 5y equals negative 20. And there it is. Okay, write an equation of the line in the form y equals mx plus b through this point perpendicular to y equals 3x plus 1. All right, so let's figure out what the slope is. So if it's perpendicular to 3x, this is 3 over 1, then perpendicular would be the reciprocal, and one of them has to be negative. Since this is positive, this has to be negative. So the slope I'm looking at is negative 1 over 3 through this point here. So how about it? Y plus 3 equals negative 1 over 3 times x plus 2. Subtract 3, both sides. We've got y equals negative 1 over 3x minus 2 over 3 minus 3. So I got to combine these two fractions. This is really 3 over 1. Get them to be the same, so I'll multiply top and bottom by 3. And therefore I'm going to end up with something here. So 3 times 3 is 9. This is 9. So I got negative 2 minus 9. So how about I rewrite this to be y equals negative 1 over 3x, and then I'm going to end up with minus 11 over 3. And that's all I need for that one. I'm writing it in this form. Next, let's see, write an equation of the line, same thing, through these points, parallel to y equals 9. So if it's parallel to y equals 9, I can look at this as two different ways. Here's a graph, and we know that the graph, or the graph of y equals 9, this is 9 here, the graph of y equals 9 is a horizontal line. So if it's parallel to y equals 9 and it's running through a negative 11 and a negative 6, which is, down here somewhere, and if it's parallel through this, the lines going through this point parallel to each other, that means this line has to be going this way if it's parallel. Not perpendicular, would be up and down. So the equation of this line would be that y equals negative 6. Another way of looking at this is to remember that a equation of y equals a number is a horizontal line, and that the slope of a horizontal line is 0. So if m equals 0, I could use that, and then I have my point and my slope. So if we do that, my equation would look like this. Y plus 6 equals m is 0 times x plus 11. Okay, so subtract 6, and we've got y equals, this is 0 times, all this is 0, minus 6. And end up with y equals negative 6. And I get the same answer. No surprise. Okay, determine whether a relation is also a function. I want to look at my x values, and the idea is the x values have to be different for it to be a function. So these are all different x values, so therefore it is a function. Here we plug in to find the value, so find f of 4. So I'm going to take the 4 and plug it in for the x. So it'll be 8 times 4 to the second power plus 7 times 4. Then you calculate that out. And when you calculate that out, you should get 156. Okey-doke. Same with this one. F of 4 again. So plug in 4 for the x. So again, you got 4 times 4 to the second power minus 4 times 4 plus 7. And again, you can use your calculator for that one. That's a good reason to. And you should come up with 55. Graph this linear equation. So here I'm going to start at 6. And then it looks like my slope is 4, so I got to go up 4 and over 1. So that'll take me off the grid. So a little trick for that would be to make this -4 over -1, which equals +4, because I need that 1 for my run. So then it'll bring me back down. So it'll go -4. I'm going to go down 4, 1, 2, 3, 4. And instead of the right, I'm going to go to the left 1. And you can see it's the same line as if you went up 4, 1, 2, 3, 4, I'm guessing here, and over 1. Approximately, it's going to be the same line. Anyway, when you draw your line, you get something like that. Oop. And that would be your graph that you're looking for. Okay, one of our favorite problems. Read whatever they're talking about. An object thrown upward, initial velocity of 26, the height of the object above the ground at any time t can be described by, get my pen back, by the polynomial function this. Find the height of the object at t equals 3. So we're just substituting again the 3 for the t in the equation. That'll give us the height. -16, 3 to the second power, plus 26 times 3, plus 554. And again, use your calculator for this. And we wind up with 488 feet. Okay, I think I did that right. Here we have find the function if p of x equals 5x minus 4, q of x equals this, find p of x plus q of x. So I got to add these together or combine my like terms. So let's see, if I add these together, I've got -5x squared. That's my only x squared term. Then I have a 5x here with a minus 9x here. That's minus 4x. And finally, -4 minus 8, which is -12. And that's my answer for number 11. Number 12, find q of x minus p of x. So if I'm going to do that, I want to put the q of x first, negative, because it's subtraction, so that's always a little trickier. So I got -5x squared minus 2x minus 6 minus this -8x plus 5. Okay, so all I want to do is combine my like terms here. So when I subtract, I'm going to subtract this binomial and I end up with positive 8x, and I'll put it underneath its like column. Positive 8x, that's an 8 by the way. And this is -1 times 5, which is -5. Okay, so then I simply combine -5x squared plus 6x minus 11. Find the domain of the rational function. Well, I can see I've got a denominator. 7 will make a 0 in the denominator, so that can't be accepted, but all other numbers can. So I'll write as all real, comma, x does not equal 7. Okay, that's for the domain. Okay, let's graph this solution set. Write it in interval notation. So I've got x is greater than -7. Here's -7. All the values of x greater than -7 are going this way. My arrowhead. And at -7, I'm going to put a parentheses based on that sign of greater than. writing it in interval notation, I've got -7 in parentheses, -7, comma, infinity. And always use a parentheses with the infinity. How about the next one? X such that x is greater than or equal to -3. So here's -3. All the values that are greater than -3 are going to the right again. And then at -3, because of this symbol, I'm going to use a bracket. And when I write an interval notation, we just copy it down. And number 16, which was problematic for many of us. Remember how we talked about that? After doing it algebraically, you could have done it algebraically, but the shortcut was to flip the two terms as they are. So that bring this x and 14, just switch it. And then you have to flip the sign. That was our secret, or pretend you're showing it in the mirror and working it left to right. X is greater than 4. So if x is greater than 4, here's 4. All of them greater than, going to the right. And at the 4, I'm going to put a parentheses. And there you go. So I've got parentheses, 4, comma, infinity, and parentheses again. All right, that was number 16. Find the domain and the range. So the domain this graph is insinuating it's going to continue the same pattern going, that little wave here. Okay, so that means my domain is going to be from from here all the way to infinity from both sides. So it's negative infinity to positive infinity. That's the domain. And the range, however, is the very highest it can go is this 1. The very lowest it goes is this -1 all the way through. So my range is going to be -1, comma, 1. And with that are brackets, not parentheses in that case. Number 18, similarly, the domain is from this point to this point. And what is that? -9 to 9. -9 to 9. And I'm going to use brackets because there's no way it can go beyond that interval. And for the range, it's similarly. Let's see, the lowest it can go is 1, 2, 3, 4. So that's -4 to +4. And brackets around those two as well. All right, here we got to graph our piecewise function. So let's see, we'll do it on this graph and then compare A, B, C, or D. So let's see, I've got f of x equals x plus 3 if x is less than 1. So let's see, what have I got here? So I'm going to graph x plus 3. Start at 3, 1, 2, 3. And what do we know? That my slope is really 1 over 1. So I'm going to go up 1 over 1. And using my dash line, I've got to satisfy this parameter of x is less than 1. So that means, well, this is at 1 here already, this point here. So then going to the left, all the values that are less than 1. So my dashed line will go this way. And at the 1, I'm going to put an open circle. Okay, the next equation is f of x equals 5, which is the same as y equals 5. So that tells us it's a horizontal line at 5. So here's 5. It's a horizontal line. It's a solid line. So I'll get this, and it's going to go something like that. Oh. And if x is greater than 1, oh, so that means I can't go to the left here. I'm going to shrink it back and go to here, where all of x is greater than 1. So this point here, I'm going to have a closed circle. So here's a closed circle at 1. Draw that a little bigger. Okay, but see if you can figure out then, is it A, B, C, or D? Okay, and it looks like it's going to be B, right? Yeah, looks like it's going to be B. Greater than 1, less than 1. So that would be B. Okay, here's our last problem. And again, we are graphing each of these. So now it's f of x equals 4x plus 2 if x is less than or equal to 0. All right, so I'm graphing this top one here. So I'm going to start at 2. My slope is 4 over 1, so I'm going to go up 4. 1, 2, 3, 4, and over 1. It's less than or equal to 0, so I can use a solid line. And it's less than 0, however. So I can go here. If my slope is 4, I can still go down 4, 1, 2, 3, 4, and over 1 this way. If you want to. 1, 2, 3, 4. What's going on here? Okay. And all of them less than 0, so my line is going to go from here to here. Okay, and at the tip there, because of this symbol of greater than or equal to, I'm going to put a closed circle. Okay, then I'll graph this second one. And this is negative 1/3 x minus 4, so I start at negative 4 here. And I'm going to go up 1 over 3. Up 1 over 1, 2, 3. And again, this is another where x is greater than 0. And it's a line of, I'm going to use a dashed line because of the inequality there. So it's going to look like this. If I could do it straight, that would be great. Okay, and this is going to have a open circle. So that's the general look of this equation, or this piecewise graph. Which one is it? And, well, it looks like it's going to be C. My line here veered off somehow. Wow, that's wild. Okay, but you can see it's going to be C. And C it shall be. All right, thank you very much.